Hi guys, I'm going to do a quick video about the resistors and series resistors in series and parallel. So as you can see, the first diagram here is the circuit shows three resistors in series, and then the second circuit over here shows that the resistors in parallel. So one of the major characteristics that we discussed in the class was where you have the current that passes through the main circuit. It passes through each and every resistor without changing in a circuit with resistors in series. And so if you use V equals to IR in this case, each resistor will experience a different voltage across them. So if I have a voltmeter attached to the ends of the resistor 1, that will read a voltage of V1, for example. So you will have V1 equals I R1 for that resistor, and for the second resistor you will have V2 IR2, and then the third resistor you will have V3 equals to IR3. Now the term that did not change was I. I stays constant throughout the going around the circuit. Now if I do the same for the resistors in the parallel circuit, well, if I take R1 resistor, you will have V I1 R1, and again V equals to I2 R2, and V equals to I3 R3. So here the current actually finds like different paths. So they take different paths and go around, and when you go around and come back to the same point over here, it has to be the same current as you started with. So for example, here you have I, and there you have I1, and on this one, on this branch, you basically have I minus I1, and then again you have I2 here, and there you have I minus I1 minus I2, and that is on the branch over here, the top one. Okay, so I3 would be the current across R3. So in each case you have the same voltage across but different current values. So if I draw a line using my green color pen that represents these dots, pay attention to the green dots that I have across each resistor. So the voltage across each resistor in a parallel resistor diagram, that would read the same V as of the battery voltage. In this case we have only one battery. Later on we will have many batteries that we will discuss. So I hope you understood what we discussed here. And now I am going to get the equivalent circuit. For the first one, then the equivalent circuit would be like this. R equivalent, and there you have the battery. I didn't add switches or anything, so this is the simplest way that I can draw it. And when I do the equivalent circuit here, that also would look like the same. However, finding the equivalent resistance for the circuit with parallel resistors is different from the one with parallel resistors. The ones with series resistors is different from the parallel version. So in the series circuit, you will have R equivalent equals to R1 plus R2 plus R3. And the thing that you have to note, the main circuit current remains as I as in before. So around the circuit you will have a current going around like this. And then if you use the Ohms law here, you will have V equals I R equivalent. That's it. Now if you do the same for the other circuit onto the right, you will have the same current. I will use the blue pen to represent current, and the current that we have as I, it is the same current that we have in the main circuit. Now when I say the main circuit, around here you have I, around there you have I. So that's basically what I meant. And then when you have the equivalent, when you replace all the resistors by an equivalent resistor, then the current that passed through the circuit would be the same as I in the main circuit. Now the difference is here, finding R equivalent takes a different procedure. Instead of finding, instead of adding all the R's together, here you have the reciprocals getting added, and that equals to the reciprocal of the equivalent resistor. So this is a place where you need to be very careful. If you guys are familiar with, I assume it is the case, adding fractions, then you can add fractions. So let me get one of the easiest. Like let's say that you have R1 equals to 2 ohms, and let's say R2 equals to 4 ohms, and let's say R3 also equals to 2. And then what will happen? We take the common denominator, and you have common denominator, and then the 2 has to be multiplied by 2, the first term, and the second term you don't have to do anything. The third term you have to multiply that by 2 again. So here you will have 5 over 4. Now one might think that we ended up with the answer for R equivalent, but it is not the case. You will have to take the reciprocal of both sides in order to get the equivalent resistance. So when you take the reciprocal, you will have 4 over 5, and that is the final answer in ohms. Now this is not in ohms, it is actually in 1 over ohm, the previous one. Now if you use the same values for the series circuit, you will have R1 I said 2, R2 I said 4, R3 I said 2. So you will have 4 plus 2 6, 6 plus 2 8, and 8 ohm for R equivalent in this case. So I was just taking an example. Now I would like to example in the sense I just took the numbers, different numbers. So when we discussed one problem in the class, and that was about series circuit, and I assigned the work like a homework for you to do the same circuit in parallel arrangement. Same resistors in parallel arrangement. So here we go. R1, R2, and R3. And let's say that we have a power source with 6 volt voltage. And then we will take R1 equals to 2 ohms, R2 equals to 4 ohms, and R3 equals to 1 ohm. Now the question asks us, I'm making these things up, but that's okay, to find the current in the main circuit. Now when I do it that way, when I mark this like this, you know that each branch has a different current in this setup, right? So I'll call it I3, I2, and I1. So they are consistent with the resistant numbering, naming the resistance. Now let's use our knowledge, what we learned earlier. We know that I equals to I1 plus I2 plus I3. And if you find I1, I2, I3 separately, then we can plug into this equation and find the net current. In order to do that, we are using V equals to IR. This is our main equation. So let me put it in a box. And then I am going to take each resistor at a time and solve for I1. And we know that across each resistor we have the same voltage, 6 volt across. So let's take R1 first. 6 equals I1, R1 is 2, and the answer for I1 is 3 amperes. Let's take R2 then. 6 equals I2, R2 is 4. So you get I2 equals to 6 divided by 4, that would be 1.5, I guess. And then you have R3. R3 is 6 equals I3, and we took R3 as 1. So I3 equals to 1. So the sum I equals I1 plus I2 plus I3, 3 plus 1.5 plus, okay, there you have 6, sorry. And there you have 6, and the answer is 10.5 amperes. 10.5 amperes, and that is the answer. So to get this, we just found we found the I3 first, I1 first, I2 first, then the I3. Now this is one way of approaching the problem, and the second way is getting the equivalent resistor, equivalent circuit. Now the equivalent circuit has the same form as before. It doesn't really change. The look doesn't really mean much here. And there you have 6 volt across the battery. And then the current going around, it's just the same I. Now in this case, I don't know, it's up to you guys to decide how to do these problems. This is the second method. I personally, I like the finding getting the equivalent circuit and using Ohm's law. But again, if the problem asks us to find the voltage drop across each resistor, then we just have to stick with the other plan. Now here we have V equals IR, but this R is not just R equivalent. So the first thing here is finding R equivalent. So R equivalent equals 1 over 2 plus 1 over 4 plus 1 over 1. Now if you are familiar with the common denominator and adding fraction, that's fine. But here we got these easy numbers, so we simply can get half is 0.5, 1/4 is 0.25, and add them up, and there you will get 1.75, and that is R equivalent, 1 over R equivalent. And we have to get the reciprocal of this in order to get R equivalent, and that will give you something like 0.57 ish. So you just have to check it on your calculator. And now I have R equivalent. I am going to use this equation and find the final I, or the net I on the circuit. So 0.57, that is my R, and let me erase this. And put 6 there. So I have 6 divided by 0.57, and that's I, and I'm sure that value comes very close to 10.5 amperes. Check it out. Now let me present a little bit of a challenging problem. Now here we have 1, 2, 3, 4, 5 resistors, and they are not necessarily arranged in parallel or in series. So in order to find whether they are in parallel or in series, we have to use the knowledge that we have already. If the resistors are in series, then the current across the resistors should be the same. If the resistors are in parallel, then the voltage across those should be the same, right? Now let's start with current. Now I am going to draw the main circuit current as I. Now when we reach to a point like this, I believe you can follow the my green pen or the red pen here right now. And when you get to the junction, it produces us 2 paths. So the current obviously goes in one direction, and I'm going to call this as I1. And then through this, it is going to be I minus I1 because some I went in one direction, so the remaining goes to this point. And again we reach to a point like this, and there you have a current, let me call it I3. And then again the branch over here carries the rest I minus I1, already I1 reduced, actually I should call this as I2, sorry, this one let's call it I2, and then this one would be I minus I1 minus I2, right? And then that current comes to this point over here. There is no branch, so it goes around and comes back to this point and again this point, and at the end it goes again as I when it reaches the source, battery source. Now if you guys look carefully here, 6 ohm resistor, here you have 6 ohm resistor, there you have 4 ohm resistor. They are definitely not in series because they have two different currents passing across. And then 4 ohm over there versus the 4 ohm down here, they are also not in series because you see that there are two different currents passing through these resistors. However, when we get to the point where you have 2 ohm resistor here, let me pick another color, 2 ohm resistor and the 2 ohm resistor over there, if you check, I mean it looks like a very complicated thing like I minus I1 minus I2, but it is the same current that is starting over here and passing through this resistor, come to this point and passing through this resistor, and when you get to this again still you have I minus I1 minus I2, that is the current that is going around, and when you get to the point over here again things change. So far we have two resistors that are in series. I hope you understood what I did, and if not you can go back and check what I did. So 2 ohm resistor over here on the end of the to the right of the circuit, those two resistors that are in magnitudes of 2 ohm each, they both undergo, or they both have same current passing through them. So what we do is we start with those two resistors and we try to reduce our circuit. Now let's go with that. I am going to highlight these two resistors over here. I mean, the students who have some electricity knowledge, they might actually find this very easy, but I am focusing on the other students. Blue area. So I am only looking at the blue area where you have 2 ohm resistor and the 2 ohm resistor, and there's more here, but we are only looking at these two guys. So the equivalent resistor over there is 2 plus 2, and that gives us 4 ohms. Now that we have reduced that part into 4 ohms, I am going to redraw the picture. So here we have 4 ohms. There you have 6 ohms. And there you have 4 ohms. And now I am going to draw the new equivalent resistor 4 ohm like that. So I'm going to put the blue area here, blue area here. This is basically coming from here. Now if you look at these two, the point over here versus the point over there. Now the point over here versus the point over there. You don't really have anything in between these points. I mean, I know that you can't see this point and this point. There are no resistors, and that point and that point there are no resistors. And I said that these lines are wires, so the yellow points are basically the same, like like you can consider them to be the same, because we are looking at wires without any resistance. Now because of that, you can say that they are in parallel. So I am going to mark them as in red, and I'm going to take the red area separate, so you will have something like this: 4 ohm and 4 ohm. And of course you have other stuff over here, but we are not paying attention to the other area, we are only looking at these two. So we are finding the R equivalent for the red area, and that would be 1/4 plus 1/4, and when you add them together that will give you 2/4, and when you take the reciprocal you will have 4/2 or 2 ohms. Now that we have reduced those two, I am going to get to that and redraw the circuit with what I have. So here you got 6 ohms, and there you have 4 ohms, and here you have 2 ohms. I'm going to mark it in red. Give me a minute to mark it in red, and that is the 2 ohm coming from here or coming from there. Now you can see that the circuit has been reduced so much, and now we are moving on, and we are looking at these two resistors, 4 ohm and 2 ohm. So I'm going to mark it in yellow. So that is our yellow area. Now if you look at those two resistors, and I am going to use these blue points, these junctions, they don't have any other branches. So whatever the current that passes through this branch would be the same going through the rest of the branches in the yellow area. Since it is the same current, we can say that those two resistors are in series. So I'm going to take the yellow area separately. 4 ohm and 2 ohm, and of course we have other stuff here but not paying attention. We are only paying attention to the yellow area. So we find the R equivalent for those two resistors by adding them like this. So here you got 6 ohm as the equivalent resistor for the resistance for the yellow area. Now the circuit is even like very simple at this point, and we got the battery, and we have the remaining 6 ohm on the branch over here, nothing changed. And now I am going to bring the 6 ohm that we just got, and I am going to mark it yellow. Yeah, now again we have two resistors, and again I mark these branches red. And if you pay attention, in between these two dots, nothing, no any like devices, no any resistors, and they can be considered as just one joint. And that is the last part we have, 6 ohm and 6 ohm, they are in parallel. And we got the final, I don't know what color to use at this point. I think we used all the colors. Okay, there you go, green area. And we are reducing that into our last equivalent resistance, and let's find what it is. What happened to the tip? So you got 1/R equivalent. Okay, the tip is way too big. equals to 1 over 6 plus 1 over 6, and 1 over R equivalent equals to 2 over 6. Take the reciprocal, that gives you 6 over 2, and R equivalent is 3 ohms. So the final answer, that is R equivalent on the circuit, that is what we were looking for. If you go back to the problem, there you have find the R equivalent, and the answer is 3 ohms. And then the battery has a voltage given to us as 4 volts. So in order to find the current, that is part B, to find the current, we can use Ohm's law. And V equals IR. V is 4, I is what you are looking for, R is 3. So I equals 4/3 amps. That's the answer for part B. And part C asks the power dissipation across the battery, and we learned power in 3 different ways, and I'm using the easiest. P equals to VI, and V is the voltage, for I is 4 divided by 3, and the final answer for power is 16 divided by 3 wattage. I mean, if you want to simplify it, you can do that. It's pretty long video. I tried to be specific as I could, but just use stop at every single place and then see if you understood what I just did. I cannot really make it more than 30 minute long because it takes forever to upload. Alright, so if you have any questions, I'll be available on Tuesday, and then we can talk.